What if I told you that some of our greatest environmental concerns could fuel their own solutions? Literally. I know, it sounds...
Too good to be true.
But it's not, with a process called Fischer-Tropsch. This molecular reconfiguration can recycle everything from renewable biomass to mountains of tires to the Great Pacific Garbage Patch. It all starts with gasification. Organic materials are those made of carbon,
Fischer-Tropsch.
the element of life. They include items
Like this cup, right?
yes, but also that plastic lid and your sweater. Carbon-based materials are added to a gasifier with water, high temperatures, and very high pressure. They undergo 4 steps that occur at the strike of a match, but because they're enclosed, there is not enough oxygen for a flame. For the sake of an example, let's use polypropylene, which makes up those pesky plastic straws. Multiplying polypropylene by bigger integers as n creates longer, stronger polymer chains. For example, multiplied by 3, it would look like this. A straw would begin its gasification process by drying at 100 to 150 degrees Celsius. Raise the temperature up to 200 to 500 degrees Celsius, and it divides into individual volatile elements and pure carbon charcoal, which can be recycled into things such as roads. Crank the heat further to 8 to 1200 degrees Celsius, and the elements break down into even lighter gases. Reducing the heat also reduces the oxygen, leaving behind a combination of carbon monoxide and hydrogen, which is called synthetic gas, or from here on out, syngas. Let's take a look at how polypropylene would break down on a molecular basis. If I rearrange the molecules, you'll see how adding H2O produces carbon monoxide and hydrogen, or syngas, which is the feedstock for, you guessed it. There are 4 types of Fischer-Tropsch reactors, which are all used today. Before World War II, syngas flowed down cobalt-filled tubes. By 1950, it circulated with iron through a heat-regulated apparatus. In 1989, they lifted through liquidized iron, and in 1993, it raised as bubbles through a slurry of hydrocarbon wax and cobalt. Those that use cobalt are set at 200 to 250 degrees Celsius, producing food-grade paraffin wax alkanes that can be hydrocracked into sulfur-free diesel. The iron-catalyzed reactors at 300 to 350 degrees Celsius produce highly reactive olefins, or alkenes, that can be left gaseous or used in clean-burning, non-drilled gasoline. Now, what could this mean for us? Energy is neither created nor destroyed. Humanity figured out how to manipulate it into detrimental states such as overwhelming plastic and even excess CO2. And if we have the chance to recycle it into that which fuels our lives, all the while saving them, it's not only a choice, but a responsibility.
And that's